NASA and ISRO launch historic NISAR satellite to monitor Earth's surface changes. Imagine a groundbreaking partnership between two of the world's fastest-growing space powers, the United States and India, launching a joint satellite mission that promises to revolutionize how we observe our planet. This historic collaboration has given birth to a first-ever satellite named NISAR, short for NASA-ISRO Synthetic Aperture Radar mission, that can detect tiny, almost invisible shifts on Earth's surface. These subtle changes could hold the key to improving how we prepare for and respond to natural disasters, potentially saving countless lives and safeguarding infrastructure. But here's where it gets truly intriguing. NISAR isn't just any satellite. It's equipped with not one, but two different synthetic aperture radars, each developed by NASA and the Indian Space Research Organization, ISRO, as part of their very first joint satellite effort. This dual radar technology uses microwaves, similar to traditional radar systems, to scan Earth's surface. However, what sets it apart is the advanced data processing that transforms those signals into incredibly high-resolution images, revealing details that were previously beyond our reach. On a momentous morning, July 30th, 2025, at 8:10 a.m. Eastern Time, or 5:40 p.m. Indian Standard Time, NISAR was launched from the Satish Dhawan Space Center on India's southeastern coast. It rode aboard ISRO's Geosynchronous Satellite Launch Vehicle, GSLV F-16. NASA shared the excitement in real time, broadcasting the launch via NASA Plus and its YouTube channel, allowing space enthusiasts worldwide to witness this landmark event. Once in orbit, NISAR will circle the Earth 14 times each day, completing detailed scans of nearly every stretch of land and ice twice every 12 days. This impressive frequency will enable it to detect surface changes as minuscule as fractions of an inch. Imagine tracking a landslide's early movements, monitoring glaciers melting, or spotting shifts in agricultural fields with this level of precision. NISAR's data will be made openly available to researchers and the public alike, fostering transparency and global scientific collaboration. What truly sets NISAR apart is how its dual radar systems complement each other. The spacecraft carries an L-band radar developed by NASA's Jet Propulsion Laboratory in Pasadena, California, which uses longer microwave wavelengths, around 10 inches or 25 centimeters. This allows it to penetrate dense forest canopies and reveal structures hidden beneath, such as tree trunks and rocks. In contrast, the S-band radar, supplied by ISRO, operates with shorter wavelengths, approximately 4 inches or 10 centimeters, ideal for picking up finer details like the rough texture of leaves or monitoring crop health. This unique combination means that NISAR isn't just taking pictures, it's measuring movement, moisture levels, and surface deformation with unprecedented accuracy by bouncing microwaves off the Earth's surface and catching the reflected signals with its large radar antenna. NISAR can peer through clouds and rain during both day and night. This capability is vital for observing our ever-changing planet under any weather condition. The mission's objectives go well beyond scientific curiosity. NISAR's continuous monitoring could alert us to subtle land movements that precede volcanic eruptions or earthquakes, potentially giving people precious time to evacuate. It can also help scientists understand how shifts in land might impact critical infrastructure like dams and levees, or track how natural disasters, such as wildfires and hurricanes, evolve, ultimately improving disaster preparedness worldwide. This ambitious mission was born out of a collaboration that began more than a decade ago, following recommendations from the National Academy of Sciences in 2007 to prioritize Earth observation. NASA and ISRO formalized their partnership on September 30, 2014, committing equal effort and resources. ISRO managed the satellite's structural design, launch vehicle, and launch service, as well as calibrating the S-band radar and developing data processing algorithms. Meanwhile, NASA contributed the large radar reflector antenna, deployable boom, communication systems, and the L-band radar. NISAR is truly a 50-50 partnership, said Wendy Edelstein, the mission's deputy project manager at NASA's JPL, emphasizing how these radars complement each other to achieve scientific results no single system could gather alone. She has personally made more than 25 trips to India, spending countless hours working side by side with ISRO colleagues, embodying the spirit of global cooperation amidst challenges such as COVID-19. Karen St. Germain, director of NASA's Earth Science Division, reflected on the significance of this union. We are two nations united with one mission. NISAR brings together the incredible talents of NASA and ISRO to study our planet as never before. This partnership builds upon previous cooperative efforts like NASA's instruments flying aboard India's 2008 Chandrayaan-1 lunar mission. From India's perspective, Dr. Jitendra Singh, Minister for Science and Technology, expressed pride in how NISAR aligns with Prime Minister Narendra Modi's vision for India to become a Vishwa Bandhu, a global friend and partner for humanity. This mission symbolizes what democracies devoted to science and global welfare can achieve together, Singh said, highlighting NISAR's role not only for India and the United States, but as a valuable resource for countries worldwide, especially for disaster management, agriculture, and climate monitoring. And here's the part most people miss. Beyond the technology and data, NISAR represents a profound gesture of international friendship and trust. It challenges us to consider what more could be accomplished if nations worldwide united with a common goal to protect our shared home. Could this kind of collaboration reshape space exploration and Earth science in the future? How might geopolitical tensions influence or hinder such partnerships? Now we turn the question to you. Do you believe international partnerships like NASA and ISRO's NISAR mission are the best way forward to tackle global challenges? Or should space exploration efforts remain more nationally focused? Share your thoughts below and join the conversation on the future of Earth observation and global collaboration. India launches NASA-ISRO satellite to track climate threats from space. Imagine a world where we can predict and prevent natural disasters, where we can track the slightest changes in our planet's surface, and where we can work together to combat climate change. This is the world that the NASA-ISRO satellite, NISAR, promises to deliver. But here's where it gets exciting. This $1.5 billion satellite is not just any ordinary satellite. It's a game changer. Launched on Wednesday from India's Satish Dhawan Space Center, NISAR is the first joint radar imaging satellite mission between NASA and the Indian Space Research Organization, ISRO, and it's set to revolutionize the way we monitor our planet. The satellite will map the entire planet every 12 days, providing data that will aid in climate, disaster, and environmental monitoring. But what makes NISAR so special? For starters, it's the world's first radar imaging satellite to use two radar frequencies, the L-band provided by NASA and the S-band developed by ISRO, to track minute changes in the Earth's surface, including movements as small as a centimeter. This means that scientists and disaster response agencies will have access to unprecedented levels of data, enabling them to monitor everything from glacier retreat in the Himalayas to potential landslide zones in South America. And this is the part most people miss. The satellite's data will be made freely available to users worldwide, promoting transparency and accessibility in environmental research and hazard response. But here's the controversy. With great power comes great responsibility. As we delve deeper into the world of space exploration and data collection, we must ask ourselves, who will have access to this data, and how will it be used? Will it be used to benefit humanity as a whole, or will it be exploited for personal gain? These are the questions that we must consider as we move forward into this new era of space cooperation. The launch of NISAR is a significant milestone in India's push to establish itself as a leading space power, following the success of its Chandrayaan-3 moon landing and its upcoming Gaganyaan human spaceflight program. But what does this mean for the future of space exploration? Will we see more collaborations between nations? Or will we witness a new era of space rivalry? The possibilities are endless, and the implications are profound. As ISRO Chairman V. Narayanan said, the potential applications from the satellite are huge, and the global scientific community is eagerly awaiting the satellite data for their respective research and usage. But we must also consider the potential risks and challenges associated with this technology. As we move forward, we must ask ourselves, are we prepared for the consequences of our actions? Are we prepared to work together to ensure that this technology is used for the greater good? The launch of NISAR is a call to action, a reminder that we must work together to address the challenges facing our planet. So, what do you think? Will NISAR be a game changer in the fight against climate change? Or will it be just another example of technological advancement without consideration for the consequences? Share your thoughts in the comments below.